Welcome to Calculus for Us. In this video we will learn how to differentiate or find the first derivative. So let's begin by understanding what differentiation is. Well, differentiation is an operation that allows us to find a function that outputs the rate of change, or the gradient in this case, of one variable y with respect to another variable x. Okay, so we need to understand the basic rule for differentiation. So let's say we've got a function of x, which is x to the power of n. Okay, to differentiate this is the rule, so it's just a sign that we use to show that we're differentiating. It would be, so n, that power, you take it down, you multiply it with x, and then you do the power minus 1, like so. Okay, and before now we put this into context, let's just learn some different notations that one might use when differentiating. So for example, if you're going to say y is equal to, let's say, x squared, when you differentiate this, you'd say y dash. This symbolizes differentiation. In this case, it would be 2x. Okay? Another way to symbolize differentiation would be dy over dx. That's another possible way to show that you're differentiating. Okay, now let's go on to some examples. This is an example. Let's try and do it. So, using that rule, so when you have any function, you do power of n. The derivative of that function would be nx to the power of n minus 1. Okay? Using this, you will differentiate this equation. So, y dash is equal to 3 multiplied by 2. You take down the power and multiply it. Then you do x. So then you do 2 minus 1, according to this rule. Minus 8. Okay, there's a 1 here, but we don't write it down. Just imagine it. There's a 1 here. So you do 1 multiplied by 8, which is just 8. X, 1 minus 1, which is 0. And just to let you know, any number to the power of 0 is equal to 1. Okay, and the 7 goes away because it has no power, so it just becomes 0. It goes away. And so just making this look a little bit neater, we get 6x minus 8, because as we said, this will become a 0, and so the x, regardless of what number it will become just a 1. So it'll be 8 to the 8 multiplied by 1, which is just 8. Okay, moving on to a different question, now a little bit harder this time. This one right here. And in this case, again, using the same basic rule, okay, we'll do y dash is equal to 5 multiplied by 3, x, and to the power of 3 minus 1, minus 6 multiplied by 4 over 3, power of x, so sorry, to x multiplied by x to the power of 4 over 3 negative 1. Okay, plus 2 multiplied by 1, remember there's a 1 over here but we just don't write it down, x to the power of 1 minus 1. Okay, so making this look a little bit more neater, we get 15 x to the power of 2 minus 24 over 3 x to the power of, so do this on the side, 4 over 3 negative 3 over 3, which is equal to 1 over 3, power of 1 over 3 plus 2, because this becomes a 0. Well, actually actually a 1 because the power equals to 0. And so that's it. Now to find the second derivative, in this case you can just symbolize it as y dash dash, what you just have to do is just basically find the same basic rule, just do it again. So you do it once, then do it one more time, and you will find the second derivative. So just do on this example. It's 15 multiplied by 2, which power of x, 2 minus 1, negative 24 over 3, multiplied by 1 over 3, x to the power of 1 over 3, negative 1, and then this will become 0, so we don't have to include it. Okay, and then you just simplify this up, and that will be your second derivative. You will know how to use second derivative when to find stationary points or maximum minimums, things like that, which we will discuss in future videos.